Class, and welcome to lesson 8.1. Today we're going to get into SOHCAHTOA and take a look at the trig ratio, the tangent trig ratio. What I want to do is make sure you're good with plugging in buttons into your calculator. Hopefully with the last lesson you started to figure out which way your calculator worked. Again, make sure it's in degree mode, ladies and gentlemen, and I'm going to ask you to pause the warm-ups here and do the answers yourself. Okay, so plug this in your calculator and let's get some answers. Hey class, welcome back. Hopefully you got these answers. Again, if you need some help, see me or see your math teacher to help you get these buttons figured out in your calculator. Again, make sure you're in the degree mode, okay? Because you could be in the rad or the gradient mode, radians or gradients mode, and still have all the wrong answers, okay? So the important thing, ladies and gentlemen, is if we set our trig ratios up correctly and just plug it in the calculator like you just did in the warm-up, then you calculator does most of the work for you as long as you set it up correctly. Okay, so let's take a look at SOHCAHTOA and what it really means and how we apply it. So we talked about last day as well the acronym SOHCAHTOA. You're going to want to memorize that as much as you can. You probably will get it memorized. So SOHCAHTOA has three different groupings. The first one, SOH, which is sine, which is the opposite compares the opposite side to the hypotenuse side. The cos, the ca part, which is the cos ratio, which is adjacent over hypotenuse. And the last one that we're going to take a look in more detail today is the TOA part. So it's the tangent ratio, and it's the opposite side over the adjacent side. This one is used more often in industry because when you're dealing with ramps or truss beams for construction, that's the one that's used the most. Okay. So ladies and gentlemen, the last ratio is the one we're going to focus on today. The tangent ratio compares the length of the opposite side with the length of the adjacent side when a certain angle is given. Okay, let's show this in the diagram below. So if we're taking a look at my angle of reference at the bottom, the opposite side is going to be across, okay, and the adjacent side is going to be here. Okay, so just think of a ramp to a building, any wheelchair access. If you're snowboarding, skiing, or skateboarding, you build ramps. Sometimes they're curved, but you do build ramps, okay? The other option, folks, can you just write that in here too, is what if my angle of reference was different? If my angle of reference was here, again, my opposite side's going to be on the bottom there, and my adjacent side's going to be there. Okay, most often or not, we're going to use that viewpoint. Okay, all right, so let's take a look using the tangent ratio to solve some problems. Okay, example 1, use this tangent ratio to solve the side length x. Okay, so what I want to do, folks, is notice this is the beginning of this, so I want you to write this down until you get the stuff memorized. But if an angle is given, that's our angle of reference. Okay, so from that angle of reference, x is what we're trying to find, and what side is it? It's the opposite side. Okay, whereas 12 is the adjacent side. Now hypotenuse has nothing on it. I'm not going to even write hypotenuse down, because what I'm going to do, first of all, is write SOHCAHTOA down. Probably do that at the top of your page too. It's going to be helpful, okay? Because we're going to mix these up eventually. But what happens is I have an O and an A. So what ratio does that tell me I'm using? The tangent, because it's the only one that has an O and an A in its three groupings. Do you guys see that? So that's how you're going to be able to differ to tell me which ratio to use, even though I told you we're just using the tangent ratio today. Okay? So what does that tell us to do? So that means that tan theta equals the opposite side over the adjacent side. So let's fill in what we know. We know tan of what angle? 32 degrees equals the opposite side, which is x, divided by the adjacent side, which is 12. Now, tan 32, folks, is a whole number, so guess what, or a whole value, so just put it over 1. And again, you cross multiply, so 1 times x is x equals the other cross, which is 12 tan 32 degrees. And that's why we were doing these in warm-ups. So again, in your calculator, folks, you either press 12 tan 32 if you've got a two-line display, or if you've got a one-line display, you're going to go 32 tan equals times 12, and hopefully you get the answer of 7.5 meters. Okay? All right. Next example. Example B. Here is my angle of reference here. So across, this is my opposite. Okay? And this is my adjacent side. Again, I have no hypotenuse, but I'm not going to write it in. And again, I've got opposite and adjacent, so that tells me I'm using the tangent ratio. So we can sub it in right away. So you go tan of the angle, which is 27 degrees, equals the these go in order. So it's the opposite, which is x, over 3.5, which is your adjacent. Okay, again, cross multiply, so it's going to be x equals 3.5 tan of 27 degrees. Okay, plug it in your calculator, folks, and you're going to get x equals 1.8 centimeters. Okay, good work. Let's take a look at the next example here. Okay. So for the next example, ladies and gentlemen, my angle of reference is 41 degrees. So my opposite side is going to be 10 because it shoots across. And my adjacent side is x. Okay. Be careful here. This is different than before. So when you go set this up, tan of 41 degrees equals, be careful here, my opposite side, which is 10, divided by my adjacent side, which is x. There are two ways you can solve this. One, cross multiply. So this time it's going to be x tan 41 equals 10. And to get x by itself, you've got to divide by tan of 41 degrees. Whatever you do to one side, do the same to the other. That's one method of doing it. Okay, plug in your calculators and you're going to get 11.5 feet, but because it's feet measurement, I'm going to use a fraction of a half. Okay, 11.5. Okay, or I'm going to show you a shortcut. Okay, so if I have tan 41 degrees equals 10 over x, I'm going to do what's called the switch. Okay, when x is on the bottom, you can do a switch. So I'm going to replace x with tan 42. So x equals 10 over tan 41 degrees. And all I'm going to write is put an arrow in and say switch. Okay? Because what you're multiplying by, you will eventually have to divide by, like what you did in this step right here. Okay? And then plug in your calculator, and you're going to get 11 and again a half feet. Don't use 0.5 even though it says in your calculator because it's imperial. All right? Okay. Moving on here, D. Okay? Here's my angle of reference. So I have an opposite side here. I have an adjacent side here. Let's fill, again, opposite and adjacent means I'm using the tangent ratio. So tan of 57 degrees equals the opposite, which is 3.7 divided by x. I'm going to use the short form, which is switch. So I write down my arrows and I put down switch. Okay. And then I'm going to switch it. So it's going to be x equals 3.7 divided by tan 57 degrees. So x equals, plug in your calculator, 2.4 meters. Okay, so folks, sometimes the triangle is given, and that's good because you don't have to draw it or guess it, but sometimes it's not. So let's take a look at example 2 here. It says, given triangle DCE, find E, so we've got to find side E, where this much information is given. When a triangle isn't given, I always look to see if there's a critical 90-degree triangle. Because again, if you got a 90-degree triangle, you're going to use SOHCAHTOA. If you don't, you have an oblique triangle, you're going to have a different method of solving. And we're going to get to that later on in the unit when we deal with oblique triangles. But what I know for sure is I'm going to set up angle C is 90 degrees. So I'm going to start with that. And ladies and gentlemen, it doesn't really matter where you put D or E. So I'll draw this triangle, or you could have it like this, ladies and gentlemen. This could be E, and this could be D. Okay, as long as you set your triangle up correctly, you're going to be fine. When I mean correctly, you got to remember where to put these. So angle D equals 34 centimeters. So D is over here. So this is 34 centimeters on this one. But this is angle D, so opposite on the second triangle, it's 34 centimeters here. Okay? And the last one we're going to take a look at, we're going to find E first. So this is what we're trying to find, E and E. And then D is 36 degrees. So 36 degrees and 36 degrees. Although these triangles look very different, folks, in terms of their order, as soon as we identify opposite and adjacent, you're going to find they're the same. So if this is my angle of reference, folks, my opposite side is 34 degrees and my adjacent side is E. Look at my second triangle here. This is my angle of reference, this is my opposite side, and this is my adjacent side. So it doesn't matter which triangle you set up, you're going to do the same thing. Okay, so we're going to go tan of 36 degrees equals the opposite side, which is 34, over my adjacent side, which is E. Okay, if you use X by chance, just at the end, put down E equals. Okay, E is on the bottom, so you're going to switch it. So E equals 34 divided by tan of 36 degrees. Okay, plug it in your calculator. E equals 46.8 centimeters. All right, so hopefully you're comfortable now, folks, with using the TOA part of the trig ratios, or the tangent ratio, and finding a side length. Let's now explore how to find the angles. Okay, so when asked to find a missing angle, make sure that you make sure it's the angle of reference. So that's the one you're going to make as your angle of reference. Remember to use your inverse buttons on your calculator when finding an angle. So for example, in question A, it says to find angle P. So that becomes my angle of reference, folks. So where do I have information? On my opposite and my adjacent. That still tells me I'm doing tangent because it's the opposite and the adjacent. Okay? So in this case, what we fill in is tan of P, because we haven't got that figured out, equals the opposite side, which is 3 over 4. Just like we did in warm-ups, folks, to find the angle, you've got to use your tan inverse buttons. So tan inverse of 3 divided by 4. Let's quickly go over that. So it's going to be second tan, opening bracket, 3 divided by 4, closing bracket equals, or if you got a one-liner, folks, 3 divided by 4 equals second or shift, then tan. Okay, so plug it in your calculator, and you should get 37 degrees. Okay, over here, example B. Here is my angle P, and so across from that is my opposite, and beside it is my adjacent. So tan of P equals opposite, which is 6.5, over my adjacent, which is 2.5. Angle P equals the tan inverse of this ratio. Plug it in your calculator, ladies and gentlemen. Again, see me if you, it's an easy thing once you figure your calculator out. Okay, and should be rounded to 69 degrees. Awesome. Let's do one word problem and then we'll get to our homework. Okay, so one word problem. A guy wire supports a tower. Okay, so think of a radio tower, one of those flimsy ones that if it's not supported by a guy wire, those are just your cables, folks, that connect them to the ground. Okay, the wire forms a 57-degree angle with the ground. The wire is attached to the ground 16.5 meters from the base of the tower. So we've got two questions here. So first thing I'm going to do is draw my diagram. So here's my tower, okay, and it says that I have a wire, so I'll put my wire right here. It didn't say it was at the top, but it doesn't matter, okay. It says it has a 57-degree angle from the ground. Okay, we assume the tower is always 90 degrees. And it said that it's 16.5 meters from the base. Okay. Okay. So, example A says, at what height is the wire attached to the tower? Okay, so we're looking for X here. Okay, so we're going to let X represent height where wire is attached. Sorry, not where. Where wire is attached to tower. Okay. And so that's for part A. So what I now need to do is decide what sides I have. So here's my angle of reference. So I have my opposite side and I have my adjacent side. So for example A, I'm going to go tan 57 degrees equals opposite over adjacent. I always like when my unknown is on top because then you can just cross multiply. So X equals 16.5 tan 57 degrees. Plug in your calculator, ladies and gentlemen. And X equals 25.4 meters. Okay, so therefore the height is 25.4 meters where wire meets tower. Great, that's example A. Now example B says how long is the guy wire? So what we need to do is introduce a new letter. So we want to find out how long is this guy wire. Okay, and let's let that be Y. So let Y represent guy wire length. I use a different letter, folks, just because it's going to be easier. And until we learn the other trig ratios, ladies and gentlemen, we're going to use what we should have remembered from grade 9, is that if you've got two sides of the triangle, you can find the third. So that's going to be your hypotenuse. So you go y squared equals 6.5 squared, which is the base side, plus the height side, which I found, which is 25.4 squared. So y squared equals 907.41. Don't forget to take the square root. So y equals 30.3. So therefore, the wire is 30.3 meters long. Awesome. Okay, folks, that's a great introduction to trigonometry. When you are doing your homework, please ignore finding the tangent value. That's where they do it to 4 decimal places before they find the answer. Just plug in your calculator. It'll do the work. And just a side note, folks, when you take a look at 4A, okay, there's 2 ways you can draw this. Okay, so don't want you to get confused. You'll make more sense when you look at it. If you have angle A here and B and C, opposite side is going to be 5 and your adjacent side is going to be 9. Or if you draw angle B here and then put angle A up top, okay, that's going to be your angle of reference and it's going to be 5 or 9. So there's 2 possible answers to set that question up. That'll make more sense when you look at the question. Awesome, guys. Have a great day and happy trigging.